Let's talk about molding specifically.
Okay.
So what parameters are most critical during PPAP validation for molded parts?
For molded parts, you're going to make sure that your tooling is set up and is attuned with the material that you're using. You're going to make sure that your temperatures and your cure times are are spot on to produce the end good that is what the customer is expecting. If we're doing molding, you know, different materials have different shrink rates. So then the tooling will have to be specifically made for that material. You can't have one tool put different materials in it and expect to have the same outcome every time. You're also looking at pressure control. You're looking at traceability back to the raw material. So we would like to, once if we have a problem with a finished good, ideally there's traceability all the way back to the raw material that was used to produce that good. You're also looking at tooling maintenance, cavity identification. Some customers will request that we have all of the cavities specifically identified. That way, later on down the line, if there are any sort of issues, you can say, okay, this is a 160 cavity tool, but we're having a dimension that is, slightly going out of tolerance and it's only for, cavities 40 through 50. When it comes back to problem solving from a quality side of things, that kind of tells us where to begin looking at the tool because it's not something that is impacting the entirety of the tool. And it might say that the processes are still fine, but the tooling itself requires maintenance. Tooling maintenance extremely important, especially as the life cycle of the product goes on. And that is another thing that might trigger, depending on the end user, another PPAP. Let's say we have a tool has been repaired, it's been repaired, it's been repaired. Now it's time to remake that tool. If it's a new tool, they're going to need a new PPAP so they feel confident about the capabilities of that tool. So we talked also about the flow rate, the different materials, so dimensional stability, right? Um, then this goes back to tooling wear. Uh, we could produce a part from a tool, the first batch, and everything is perfectly within specification. If we run 100,000 more parts from that same bat or from that same tool, they may not have the same dimensional specifics as that first batch. So dimensional stability really ties in with tooling maintenance. You want to be able to track that over time to ensure that you're being proactive instead of reactive when it comes to any sort of dimensional issues. Flash, when we're dealing with molded goods, is also another thing. The tool itself can be produced in a way to minimize the amount of flash on a good, but that's where those secondary processes also come in because the factory could be doing an additional step, such as cryogenic deflashing, to remove excess flash.